Okay, now let's edit our code over here a little bit so that we can see how do you return by reference. Pretty simple actually, much like we've seen in an earlier video about returning a pointer. All you gotta do is declare that the function will be returning a reference by using the ampersand symbol of whatever type it is you'd like to return. In this case, I would like to return a reference of the type integer. Now let's modify the definition, and there we go. And because right now we declared and we are defining that this function will be returning a pointer and this function will be returning a reference, as we learned, we can no longer leave these functions without a return statement. These functions right now must have some sort of minimal valid return statement. So in the pointer function over here, I could return either just the plain old pointer that we happen to have hanging around in our function over here, or maybe in some cases we'll be returning some other kind of integer pointer, like maybe we will try to allocate new memory on the free store and return that memory address as the pointer that we're going to return. I wouldn't do this very often because it's usually a better idea, as we learned, to have the same function delete the memory that it itself has allocated, whereas over here we are allocating new memory during the return statement, which puts the responsibility of deleting this new memory to the calling function. So let's just keep it simple for now and just return a plain old pointer. And now in the reference function, pretty much the same thing. I will be returning some sort of valid object that can be accepted as an integer reference. So either I could just pass back the plain old reference that we happen to have hanging around over here, or maybe I'll return some other integer reference that I had hanging around, or maybe I'll just return some integer itself that I have been using in this function, and this plain old integer will be accepted as a valid reference, as we said that the program will automatically assign a integer as a integer reference. Just like when we passed a integer into this function, we just passed a plain old integer, and it was accepted not as an integer, but as an integer reference. The same thing when returning by reference, we could return a plain old integer variable, and that will be a valid expression to be returned as an integer reference in the calling function. So right now, these two functions over here actually return something. So as we learned, we could take advantage of that and grab whatever it is that they are returning and make use of it, for example, to assign it to some pointer or some other acceptable item. As a matter of fact, if you're paying attention to what's going on over here, I am right now calling this function that returns an integer reference, and what's happening at the return statement is pretty interesting. I am returning not an integer reference, but an integer variable itself. But as we learned, the integer variable itself can be converted into an integer reference because the program will automatically do that for us. So we are returning a regular integer variable, which is now going to be considered as an integer reference. It's going to be translated as an integer reference, and that integer reference will be returned to this place right over here. Now I'm taking that integer reference and assigning it back to a plain old integer variable. And what's happening again is that we are sort of switching what types of objects we are dealing with here, whereas you may have expected that we're supposed to assign the return value to a reference, to an integer reference. I mean, come on. The return value of this function is an integer reference, so that, by all means, should be assigned to an integer reference. Well, the good news is that you can assign one to the other with no problem whatsoever. An integer variable and an integer reference can be assigned one to the other, which is why this plain old variable is accepted as a reference, and this reference that is returned from this function is right now being converted or assigned to a variable. If you would have wanted to do something like this with the pointer function, meaning if you would try to take the pointer that is being returned from this function and assign that to an integer variable, you can't do that without first dereferencing whatever's coming out of this function. And dereferencing, of course, as we learned, is by using the asterisk symbol. And for clarity, you might want to use an extra pair of parentheses. So what's happening right here is that this function is returning a pointer to integer, and we are right now going to dereference this pointer to integer that's coming out of this function. And once we dereference the pointer, then whatever value it was pointing to will now be assigned to this integer variable z. So just compare this line and tell me which one between pointers and references is the most clear and simple one to use. Very obvious, isn't it? Well, guess what? References don't come without their own disadvantages and problems, much like many of those that we saw with pointers. One terrible problem which you should always keep in mind is actually one that we've been doing right over here. Do you see any problem whatsoever with what's going on over here, where we are creating a local variable and we are returning that to be used as a reference, which will be returned to the called function? And now maybe the called function will take that reference that is returned and assign it to some other local reference. See any problem whatsoever over here? Well, here's a problem. If you remember, we said in last video that every reference is tightly coupled with the variable that it is referring to, which is why you must initialize a reference immediately upon creation of the reference. And this reference will forever be constantly pointing to this variable. It will always be referring to this variable for the rest of its life, and you will never be able to change it to point to refer to any other variable. However, here's what's happening over here. In this function, do something ref, we are creating a local variable, myInt, and we are returning myInt to be used as a reference, which will be assigned to a reference in the main function. The problem is that as soon as this function returns, myInt totally and absolutely disappears. It gets destroyed. It absolutely no longer exists. And so this reference which was returned to the calling function and which was now assigned to this reference is totally invalid. This reference is right now referring to a variable that does not exist. And that is a most horrendous violation of the protocol. And from this point forward, your program is in a situation of undefined behavior. And if you try to use this reference even once, all I can say is may God help you. It's like we found a little crack where we can sneak behind and break the rules of C++ by making a reference which always must refer to a valid variable. Right now we are making this reference referring to a totally inexistent variable. So the lesson is always make sure that whatever your references will be referring to exists. So references should always be referring to some variable that exists in a previously called function or inside of some class or something that's still around, that still exists. And try to make sure that your references will disappear, will be destroyed, at the same time that the variables they are referring to are destroyed. You don't ever want to find yourself in a situation where you have a reference that is not referring to a valid, usable, normal variable or object. So we could say that's one up for pointers, where it's a little bit convenient sometimes when you need to have a pointer that is not yet initialized, that is not yet pointing to anything, and you'll only be using the pointer a little bit later on to point to something. But meanwhile, you need it to be in some sort of neutral state where it's not pointing to anything. That kind of gets useful every once in a while. However, with references, from the instant they are created, they must immediately be pointing to some sort of variable. They must refer to some valid variable immediately, and that variable must constantly exist throughout the whole lifetime of the reference, or else you will end up with undefined behavior in your program. As once again, in contrast to your pointers, which can point to nothing, and then they could point to something, and then you could make them point to nothing again, As you see right over here, this is all valid C++ code with pointers, however, very much not so with references.